Frequency, wavelength, and wave speed are all related because of the equation wave speed equals wavelength divided by time, or wave speed equals frequency times wavelength. But before we get into the equation, let's look at this diagram and break it down a bit. So the first thing I'm going to talk about today is frequency. So it's the number of waves that pass a given point in 1 second. And you should also note that frequencies also are measured in hertz and that there are low and high frequencies. And as you can see on the diagram. And as you can see, high frequencies have more peaks on their waves compared to low frequencies that have less peaks on their waves. The second component we're going to look at today is wavelength. And what a wavelength is the distance between two peaks, and that is measured in meters. So as you can see on the diagram, lower frequencies usually have longer wavelengths compared to a higher frequency that has shorter wavelengths. So lastly, we have wave speed, which is the distance the wave travels in a given amount of time, and that is measured in meters per second. This here in the next slide is going to be a simulation of a wave, both around 10 seconds, and the first sound you will hear is a low frequency and long wavelengths, and the second sound is a high frequency with shorter wavelengths. So now, since we have each of the component and we know what they mean, let's put it together and do some math. Using the equation wave speed equals frequency times wavelength, let's solve this problem. Find the frequency of a wave with wavelength 2.5 meters and speed 50 meters per second. First, you want to look at the components that you have, which is wavelength 2.5 meters and speed, which is 50 meters per second. So you are looking for frequency. Another visual, let's look at this diagram here. These diagrams are different ways you can find the different pieces that you need. So as you can see, if you're looking for wave speed, you're going to use the top diagram, frequency, which is what we need, which is the middle diagram, and wavelength, which is the bottom diagram. So using our equation, frequency equals wave speed divided by wavelength, we can plug our numbers in. So 50 meters per second divided by 2.5 meters gives us 20 hertz.